at the farthest reaches of our solar system. Nearly 4.5 billion kilometers away lies a cold and mysterious planet named Neptune. Discovered in 1846, it stands out with its distinctive blue color. It is the 8th planet in our solar system. This planet is home to monstrous storms, with wind speeds that can reach up to 2,100 kilometers per hour, faster than any storm on Earth. What force has created the Great Dark Spot, a colossal storm the size of Earth, yet mysteriously vanished after only a few years? From its internal radiation heat source emitting 2.6 times more energy than it receives from the sun, to its system of 14 rich moons. It stands as proof that in the universe, the most illogical things can be the truth. Let's explore the untold secrets of Neptune, a planet we are just beginning to understand. Despite its distant location in the solar system, this planet harbors an energy and temperature mystery that scientists have yet to fully explain. Neptune, located over 4 billion kilometers from Earth and receiving less than 1/900th of the sunlight that Earth gets, has a strange characteristic that no other planet in the solar system possesses. This planet emits 2.6 times more energy than it receives from the sun. Now, this creates a paradox in temperature that scientists cannot immediately explain, especially when compared to similarly sized Uranus, the nearest planet to Neptune. Despite being closer to the sun, Uranus is much colder. Why does a planet so far from the sun emit more energy than it receives? Numerous studies from Voyager 2 and modern telescopes have confirmed this intense energy emission from Neptune, making it one of the planets with the most powerful internal energy sources in the solar system, second only to Jupiter and Saturn. Scientists have long wondered about the source of this energy. But what exactly is creating such a powerful energy source? Is there some mechanism within this planet that keeps Neptune vibrant and alive? To explain this energy emission, astronomers have proposed two main hypotheses, both related to the planet's formation and deep internal structure. One popular hypothesis is that Neptune has retained a significant amount of heat from its formation, known as the primordial heat remnant theory. During the chaotic early universe, as matter from cosmic dust clouds began to condense and form planets, the gravitational contraction of the material generated a large amount of heat. This heat was then trapped inside Neptune's core, and it continues to be released to this day. If you love exploring, make sure to hit subscribe on WUFO now so you don't miss the next discoveries. After delving into the strange energy sources and supersonic winds of Neptune, the next question is, what makes up the structure of this planet, where everything seems to differently compared to other planets in the solar system? To understand this giant ice planet better, we must delve deeper into Neptune's atmosphere, mantle, and core, where the strange physical and chemical conditions are only beginning to be unraveled by science. Neptune is not like the other gas giants, such as Jupiter or Saturn. But instead, it possesses a unique structure. The internal structure of Neptune is a labyrinth of bizarre states of matter, completely different from anything we see on Earth or other gas planets. The atmosphere of Neptune is mostly composed of hydrogen and helium, the two most common elements in the universe. But what's distinctive is the presence of methane, which makes up a small but significant amount, enough to create the planet's characteristic deep blue color. However, the importance does not lie only in the atmospheric surface. Beneath this atmosphere, there is a special ice mantle, where volatile compounds such as water, ammonia, and methane are compressed under immense pressure and transform into superheated liquid. This is superionic ice, a form of matter with a strong electrical conductivity that generates Neptune's magnetic field. This mantle is unlike any ice we know. Under extreme pressure, the superheated liquids in the mantle become electrically conductive and ionized. It is this superodic ice that generates Neptune's magnetic field, creating a strong magnetic region surrounding the planet. But what makes us take notice is the immense pressure Neptune creates inside. As we go deeper into the planet's mantle, this pressure is 7 million times that of Earth's atmospheric pressure, equivalent to the pressure that could alter chemical compounds beyond recognition as we know them. When carbon compounds like methane are compressed under such immense pressure and temperature, they no longer remain in gas form. Carbon separates from hydrogen, and under these extreme conditions, carbon begins to crystallize into diamonds. So, when these diamonds form, they don't just fall. They accumulate into large diamond chunks and sink into the planet's core. This can be simulated through hydrodynamic models and laboratory experiments, where scientists have tested ultra-high pressure conditions similar to those inside Neptune. The simulation results show that diamonds can cluster into large chunks, and the gravitational force of Neptune pulls them deeper into the planet's core. What's special is that the formation and deposition of these diamonds is not just a theoretical phenomenon. With advancements in research technology and physical experiments, scientists at laboratories like SLAC have used high-energy lasers to simulate extreme pressure conditions, compressing materials to levels equivalent to those on Neptune. The results were instant nano-diamond crystals, proving that diamond rain is not just a theoretical possibility, but a real physical process. Scientists continue to study and understand the formation of compounds and diamonds under such extreme pressures. Could we find other planets with similar or even more extreme conditions than we can imagine. If the internal structure of Neptune generates powerful heat, creating extremely unique conditions, the next question is, how is this kinetic energy released into the atmosphere? Creating super fast winds and gigantic storms. These powerful winds and massive storms make Neptune the planet with the most extreme weather in the solar system. One of the most bizarre and fascinating features of Neptune is the extreme wind speed it possesses. At the equator of Neptune, winds can reach speeds of up to 2160 kilometers per hour, much faster than any storm on Earth. This speed is nearly twice the speed of sound in Earth's atmosphere, creating a supersonic jet stream. How can a planet so far from the Sun, receiving only 900 times less energy than Earth, sustain such a powerful kinetic flow? The answer may lie in the unique physical mechanisms within Neptune's atmosphere. Although the planet receives only a fraction of the energy from the Sun, this energy is converted extremely efficiently due to the interaction between the planet's internal heat source and its rotation. Studies show that the energy emitted from deep within Neptune not only stays trapped, but also drives strong convection currents in the planet's atmosphere, creating powerful winds. To understand the mechanism that creates super strong winds, we need to examine the relationship between internal energy, thermal convection, and the planet's rotation. One of the key factors is Neptune's internal heat. As discussed earlier, this heat creates a strong temperature difference between Neptune's atmospheric layers, making the atmosphere not just static, but highly dynamic. The thermal convection process starts from within the planet, where energy from deep inside is released and affects the atmosphere, generating strong convective currents that drive the winds. Another factor that enhances the wind strength is the Coriolis effect, which distorts the convective air currents, turning them into giant horizontal wind bands. These wind streams are not only powerful but also stable, forming supersonic jet streams that extend across the planet's surface. What's especially remarkable is that the winds at Neptune's equator move in the opposite direction to the planet's rotation, creating a phenomenon known as retrograde motion. This can partly be explained by the complex interaction between Neptune's magnetic field and the electrically conductive super ice layer beneath its atmosphere. This magnetic field may play a role in directing and altering the wind's direction, causing them to flow opposite to the planet's rotation. But powerful winds aren't the only phenomenon that makes Neptune's atmosphere so strange. The massive storms, known as the Great Dark Spot, have prompted scientists to explain these unprecedented atmospheric phenomena. The Great Dark Spot is a massive anticyclonic storm system the size of Earth, first recorded by the Voyager 2 spacecraft as it passed by Neptune. This storm shares similarities with Jupiter's Great Red Spot, but there's one major difference. The Great Dark Spot is a temporary phenomenon, unstable in nature. After its discovery, The storm disappeared in 1999 when the Hubble Space Telescope observed Neptune again. Why are the vortices on Neptune unstable compared to Jupiter's? Some studies suggest that this instability is due to the strong interactions between Neptune's atmospheric layers. Instead of being a simple two-dimensional vortex, the Great Dark Spot may be a three-dimensional phenomenon, with a more complex nature and prone to disruption by powerful convection currents from below. Large, bright clouds, which may contain methane crystals, could also play a role in the formation and disappearance of these storms. The interaction between atmospheric layers and the shifting clouds has made these storms unstable and easily disrupted. This is one of the peculiar features of Neptune's atmosphere, making these storms a mystery that has yet to be fully explained. After exploring the super-powerful winds and massive storms, one of the most fascinating aspects of Neptune is its tilted magnetic field and the unusual auroras it generates. Neptune has a special magnetic field, completely different from most planets in the solar system. When Voyager 2 approached Neptune in 1989, scientists discovered that the planet's magnetic field was tilted about 47 degrees from its rotational axis. This is unusual because most planets in the solar system have magnetic fields that are nearly aligned with their rotation axis. However, Neptune's magnetic field is misaligned and off-center. Why does a planet have such a misaligned magnetic field, and what mechanism creates this? Neptune's magnetic field is not centered within the planet, but is strongly displaced toward one side. This contrasts with planets like Earth, where the magnetic field is generated by a solid metallic core at the planet's center. Neptune's magnetic field isn't generated by a molten metallic core like rocky planets, but instead by a conductive fluid layer. This layer contains compounds such as water, ammonia, and methane, compressed under extreme pressure, which have strong electrical conductivity. The interactions and convection in this superionic fluid layer generate electric currents that move through the mantle, creating a strong magnetic dynamo effect. The turbulence within this fluid layer not only helps produce the magnetic field, but also explains why Neptune's magnetic field is multipolar, distorted, and asymmetric. This contrasts with Earth's dipolar magnetic field, which has two clearly defined opposite magnetic poles. With the shell dynamo model, Neptune's magnetic field lines don't run straight. They are bent and widely spread out, making the planet's magnetic field asymmetrical and complex. One of the most unique phenomena related to Neptune's tilted magnetic field is the SAR auroras. These are a special type of optical emission, faint red in color. Which cannot be observed by the naked eye from Earth. Star auroras are produced by an interaction between charged particles and atoms in Neptune's atmosphere. But what makes this process so unique is that it differs from the auroras typically seen on other planets in the solar system. This is because Neptune is so far from the Sun that solar winds aren't strong enough to generate powerful auroras like those seen on Earth. The SAR auroras are evidence of thermodynamic interactions in Neptune's magnetosphere. Where charged particles from space enter the planet's atmosphere, creating this phenomenon. What intrigues scientists about the auroras on Neptune is their location. While most auroras on planets like Earth concentrate around the magnetic poles, auroras on Neptune frequently appear at mid-latitudes, This is a direct result of Neptune's 47-degree magnetic field tilt. Neptune's magnetic field lines are bent. Causing auroras to appear at latitudes unlike those on other planets. The bending of magnetic field lines means they don't just concentrate at the poles. But also connect Neptune's atmosphere with interplanetary space at various points. Creating unusual energy gateways that allowed charged particles from interplanetary space to enter Neptune's atmosphere. Causing auroras in regions other than the traditional polar areas. These features of Neptune's magnetic field and auroras open up a strange world that we have never seen on any other planet. This moon is unlike any other in the solar system. As Triton has one incredibly unusual feature. Its retrograde orbit, meaning it moves in the opposite direction of Neptune's rotation. This has raised many questions about the formation of Triton. One hypothesis suggests that Triton is not a native moon of Neptune. But rather a body that originated in the Kuiper Belt. A region filled with icy and rocky objects beyond Neptune's orbit. Scientists believe that when Triton was captured by Neptune's gravity, it caused a major shift in the structure of the planet's moon system. Especially for objects in the Adam's ring. Where smaller moons were disrupted and their orbits may have been altered. Triton's retrograde orbit has drawn attention not only for this peculiarity, but also due to the strange geological activity it exhibits. Particularly the phenomenon of cryovolcanism. When Voyager 2 passed by Triton in 1989, it captured images of geysers erupting from the moon's surface. Prompting scientists to rethink the geological activity of moons orbiting distant planets. These cryovolcanoes may occur when Triton's interior temperature is high enough to melt icy materials. Creating pressure that forces the ice to erupt onto the surface. This heat may come from the Moon's internal radioactive decay or from tidal forces exerted by Neptune. Which provide enough energy to sustain this geological activity. An intriguing question arises. What energy source is sustaining Triton's geological activity? Recent experiments and simulations suggest that tidal forces from the interaction between Triton and Neptune may be the key to preventing the Moon's internal materials from freezing solid. Creating a warm enough environment inside to trigger these cryovolcanic eruptions. Triton's retrograde orbit and its unique geological activity not only affect its own dynamics, but also have a profound impact on Neptune's Adam's ring, the region containing icy objects. The Adam's ring is unstable, and Triton's appearance may have been the catalyst for the changes in the orbits of objects in this ring. Triton may have disrupted the orbits of other moons in Neptune's system. Moons like Galatea and Despina play a crucial role in maintaining the stability of the Adam's ring. But Triton's retrograde orbit has made their role more complex in stabilizing Neptune's moon system. This not only demonstrates the powerful interaction between Triton and Neptune, but also opens new avenues of research on shepherd moons and and their influence on icy bodies in the rings. In addition to Triton, Neptune has several distant moons such as Neso and Psamathe. With orbits that extend up to 25 years. These moons are far away, and their presence provides valuable insights into the formation of Neptune's moon system. The existence of these moons helps us better understand the evolution and interactions of icy bodies within Neptune's planetary system. And shows us the formation and development of moon systems in the universe. These distant moons also open up hypotheses about the formation and evolution of moons in the cosmos. Triton, with its retrograde orbit and strange geological phenomena, will certainly continue to be an exciting subject of study in future exploration missions. Neptune is a living testament to the complexity and constant change within the universe. A colossal climate machine with supersonic winds. Storms that surpass anything we know on Earth. This reveals a stunning truth. A planet located billions of kilometers away can still operate according to incredibly complex dynamical physical principles. The internal heat of Neptune has challenged theoretical models about the cooling of exoplanets. And its great dark spots, which appear and disappear unpredictably. Stand as proof of an atmosphere that is constantly in flux. This serves as a powerful reminder that every planet carries a unique cosmic lesson. The exploration and understanding of Neptune are key to unlocking the mysteries that await discovery in exoplanetary systems. Affirming that space is never mundane. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.